Hi everyone, my name is Morgan and today I'm going to be talking about the infamous lac operon. There are some vocabulary terms that you need to understand before we get started, so pause this video and familiarize yourself with these definitions. Okay, so now we're going to get started. There are lots of different forms of regulation and I'm going to begin by talking about positive and negative control. In positive control, our regulatory protein is an activator that activates transcription. You can think of positive control like this. The green person is the activator, and they are opening the door, allowing for transcription to occur. The opposite of positive control is negative control. Negative control is when the regulatory protein is a repressor that inhibits transcription. The red person is a repressor that does not allow transcription to occur. Moving on to inducible and repressible expression. When you hear the word inducible, you need to immediately think off until on. Transcription is off until it is turned on. So it's off, but then we have our effector protein that is turning transcription on. We have our light switch going from off to on. And you can remember this by I turn on. When you think of repressible expression, you need to think on until off. So our transcription is on, and then we have our effector protein that is blocking transcription this time. And here you have your light switch going from on to off. And you can remember this by the saying, he ran off. We can combine the different modes of regulation so that there are 4 possible regulatory systems. The lac operon is regulated by negative inducible regulation and positive inducible regulation. Before we get into the specifics of the lac operon, go ahead and pause your screen again to familiarize yourself with these vocabulary words. This is a visual representation of the lac operon. To the left in orange, you have your regulator gene, lac-I, which transcribes and translates the repressor protein, which is the little molecule shown in yellow. To the right, you have your promoter gene, lac-P in green, where RNA polymerase binds. You then have your operator gene, lac-O in red. Then you have the structural genes like Z, lac-Y, and lac-A. So now we're going to talk about negative inducible regulation of the lac operon, and there are 2 possibilities. Lactose is either going to be absent or present. Keep in mind that our repressor is constantly being made, so when lactose is absent, the lac repressor is going to bind to the operator. This makes it where RNA polymerase cannot bind to the promoter, so our structural genes will not be transcribed. When lactose is present, lactose is being converted into allolactose by beta-galactosidase. Remember that beta-galactosidase is transcribed and translated from the lac-Z structural gene. So this allolactose is then going to bind to the yellow repressor protein, and when it does this, this makes the repressor protein unable to bind to the operator. So with nothing in the way, RNA polymerase will be able to bind to the promoter and transcription will occur. With positive inducible regulation, we have the combination of molecules called the camp-cap complex. What this complex does is it will bind to DNA near the promoter and enhance transcription. There's an inverse relationship between glucose and camp. So when glucose is low, camp is high, and with high camp-cap complex, transcription will be enhanced. Oppositely, when glucose levels are high, camp is low, so minimal transcription of the lac operon will occur. Now I want to go through some questions that you might encounter on homework or exams. Take time to pause after each question is presented so that you can determine the solution for yourself. Then click play to see if you are right. If glucose and lactose are present, is the operon on or off? It's going to be off because cap is not bound. If glucose is present but lactose is absent, is the operon on or off? The answer is off because the lac repressor is bound and cap is not bound. If glucose and lactose are both absent, is the operon on or off? And it's going to be off because the lac repressor is not bound. If glucose is absent but lactose is present, is the operon on or off? It is on.